Hello, good morning. Student friends, in last lecture, we were discuss about rearrangement reaction of a nitrous acid and substitution reaction we have studied. In this lecture, we are going to see one more type of a reaction, that is elimination reaction. Basically, our topic is a relation between conformation and chemical property. That is how conformation, how stereochemistry affect the rate of the reaction. So here in case of elimination reaction, how stereochemistry affects the rate of elimination reaction is we have to study under this topic. Now see here elimination reaction. In elimination reaction, E2 elimination reaction, 1-1 elimination, 1-2 elimination, 1-3 elimination, different types of eliminations are there. 1-2 elimination reaction we have to study under this topic. So here under 1-2 elimination, E2 elimination is that is elimination, bimolecular elimination reaction. In elimination reaction, when E2 elimination reaction perform best, or when E2 elimination reaction takes place easily, when eliminating groups are conformationally transdiaxial or anti with respect to each other, at that time elimination reaction will be possible. The transdiaxial situation, remember, transdiaxial situation is also called as a stereoelectronic factor. Transdiaxial situation is also called as a stereoelectronic factor. That is, eliminating groups must be anti with respect to each other. So here how conformation affect the rate of elimination reaction? See with the help of one example. In steroidal derivatives, trans-diaxial vicinal dibromide reacts with iodide reasonably rapidly to give olefin, bromide ion and iodine, whereas the corresponding trans-equatorial axial dibromide reacts extremely sluggishly. Now see this example, trans isomer. This is cholesterol, steroid molecule is there, steroid molecule आहे आणि ह्या संपूर्ण मॉलिक्यूल कडे लक्ष देऊ नका जास्त, फक्त इथे या दोन ब्रोमाइड वरती लक्ष कॉन्सन्ट्रेट करा. ट्रान्स, what is the question is that why these three reactions, these two reactions, why this reaction is faster as compared to this. So see, a transdiaxial situation is present here, and therefore when potassium iodide is added, I minus attack on the Br and two Br molecules are given out, and the reaction type is a dehalogenation reaction. See here in this way, I minus attack on Br and dehalogenation takes place here. So here fast rate of reaction, formation of olefin. This is a type of E2 elimination reaction. The leaving groups are present on the adjacent carbons. And why fast rate of reaction? Why faster rate of reaction? Reason is that why fast rate of reaction? Reason is that the stereoelectronic factor. Stereoelectronic factor means the eliminating groups are anti with respect to each other, or the angle between the eliminating group is 180 degree. the stereoelectronic factor if available or present, then a rate of the reaction will be faster. In case of second isomer, here trans EE isomer, that means initially the di-equatorial isomer and it is converted into diaxial one. Here in case of second isomer, di-equatorial isomer, first step is the equatorial first ring A is converted into boat conformation first. In boat conformation, then bromide will become diaxial and then elimination. Diaxial elimination takes place, U2 elimination takes place, the formation of double bond. So double bond is present in boat conformation. This is unstable. Further conformational change, formation of olefin. So here again stereoelectronic factor is required, but why here fast and why here slow rate of reaction? The reason is that here trans-diaxial situation is available, but in case of di-equatorial isomer, this is not this is diaxial, but this is in a boat conformation. If convert this boat into chair, these two bromine becomes di-equatorial, and therefore question is that di-equatorial isomer rate of the reaction is slow because di-equatorial isomer directly not reacts with elimination reaction. Di-equatorial isomer first converted into boat conformation and then diaxial situation is attained and then elimination takes place. So in boat conformation is unstable and therefore the reaction require a time to react and slow rate of reaction. So important factor in case of elimination reaction is a stereoelectronic factor should be available. Then see here very important question, many times asked in the examination, predict the products, or sometimes question may be asked like that. Dehydrohalogenation of methyl chloride by base gives 2-menthene and neomethyl chloride gives 3-menthene. Neomethyl chloride reacts with base about 200 times faster. हा प्रश्न जरा समजून घ्या. ह्या प्रश्नामध्ये दोन भाग आहेत. एक आहे की रिॲक्शनचा टाईप कुठला आहे? डिहायड्रोहॅलोजिनेशन रिॲक्शन. डी मीन्स टू रिमूव्ह, हायड्रोहॅलोजिनेशन म्हणजे हायड्रोजन आणि हॅलोजन म्हणजे ही इलिमिनेशनचाच E2 इलिमिनेशनचाच प्रकार आहे. डिहायड्रोहॅलोजिनेशन म्हणजे रिमूव्हल ऑफ HX, that is hydrogen and halides. Now dehydrohalogenation of methyl chloride by base gives 2-menthene. So this is methyl chloride and dehydrohalogenation reaction takes place, formation of 2-menthene as a product. See here. This is a 2-menthene and neomethyl chloride gives a 3-menthene as a major product. This is the first question. Why? And second question is why neomethyl chloride reacts faster as compared to methyl chloride. Here rate is K is equal to 1 and here rate is K is equal to 200, that is 200 times faster as compared to methyl chloride. So neomethyl chloride reacts 200 times faster as compared to methyl chloride. What is the reason? Now reason is that see here why neomethyl chloride reacts faster as compared to methyl. Now let us see first. आपण पहिल्या सुरुवातीला काय बघूया की neomethyl chloride 3-menthene major product का देतो आणि methyl chloride 2-menthene major product का देतो. Now let us see first neomethyl chloride. If you convert, neomethyl chloride means Cl is beta oriented in this structure, and what is methyl chloride? The Cl is alpha oriented. Now let us see neomethyl chloride. When neomethyl chloride if you convert this planar structure into conformational structure, and if you observe this structure, it has been found that Cl and H are anti with respect to each other. There are two hydrogens anti with respect to chlorine, and therefore there are two possibility of formation of a product, that is the 3-menthene and 2-menthene. If this hydrogen is involved in the elimination reaction, formation of 3-menthene, and if this hydrogen is involved in the elimination reaction, formation of a 2-menthene. But out of these two, the 3-menthene form will be the major product. What is the reason? The reason is that the 3-menthene is a more substituted product, and according to the set-zip rule, more substituted product is formed as a major product. More substituted product is formed as a major product in which reaction? In an elimination reaction. So here this is a set-zip product and therefore more stable. Now second, if you see methyl chloride, if you draw the structure of methyl chloride, it looks like that. In methyl chloride, chlorine is equatorially oriented and there is no any hydrogen exactly anti with respect to this Cl. That is a stereoelectronic factor required for anti-elimination is absent in case of methyl chloride. Then molecule is flipped, that is flipping takes place here. Why flipping takes place? In order to attain a transdiaxial situation, molecule flip, and after flipping of this molecule, bulky isopropyl group towards axial side, CH3 goes towards the axial side, and all Cl also goes toward the axial side. Now here stereoelectronic factor becomes available, Cl axial, hydrogen axial, that is eliminating groups anti with respect to each other. So here stereoelectronic factor becomes available, that is transdiaxial situation becomes available, which is required for it to elimination reaction. But conformation becomes highly unstable. Now when base is added, elimination takes place, formation of 2-menthene as a product, but this molecule is highly unstable, therefore conformational change again takes place and formation of stable product, that is both bulky groups goes toward the equatorial side and 2-menthene formation takes place. So 2-menthene, only one product is formed in this case. This is all about the major product formation. Now second question is that why neomethyl chloride reacts 200 times faster as compared to methyl chloride. Why neomethyl chloride reacts 200 times faster? So fast rate of reaction is due to the presence of stereoelectronic factor. Here two hydrogens are available and therefore fast elimination takes place. In case of methyl chloride, stereoelectronic factor is absent and therefore molecule required to flip in order to achieve the transdiaxial situation. So addition of one more extra step, that is conformational change. Now this step to this step conversion is a rate determining step. It is a slow process because when flipping takes place, all bulky groups goes toward the axial side and it is an unstable situation. So conversion of this conformation into this conformation is a highly energetic step and it is therefore a slow step. And slow step, that is the rate determining step, it affects the overall rate of the reaction and therefore methyl chloride reacts 200 times slower as compared to neomethyl chloride. So this is all about the dehydrohalogenation of methyl chloride and neomethyl chloride in presence of base. Now one more type of reaction here. Stereoelectronic factor is a very important factor. Stereoelectronic factor is required for elimination reaction as well as epoxidation of halohydrins also. If you see, epoxidation reaction means epoxide formation reactions, And halohydrin means the adjacent carbon carry halogen and hydroxy group. This is called as halohydrin. So example, 2-alpha chlorocolestane, if you count from this carbon 1, 2, you can count from this carbon 1, 2. 2-alpha chlorocolestane 3-butyl is cyclized to the epoxide several thousand times more slowly than the 3-alpha chlorocolestane 2-butyl. Explain. This isomer reacts faster as compared to this isomer. This is the question. And why? Explain. So if you see here, halohydrin epoxide formation require a basic condition. In basic condition, most acidic proton is abstracted by the base. Negative charge will be formed on the oxygen, and this negative charge will attack on backside of the chlorine. Cl minus is given out, formation of a epoxide. So epoxidation reaction is very simple reaction. But when epoxidation reaction will be fast when the transdiaxial situation is available, that is the eliminating groups and attacking groups are anti with respect to each other, or diaxial, antidiaxial, then and then epoxidation reaction will be faster. Here in case of 3-alpha chlorocolestane 2-butyl, transdiaxial situation is present, stereoelectronic factor is present, and that's why fast epoxidation reaction. On the other hand, here in case of 2-alpha chlorocolestane 3-butyl, 2-alpha chlorocolestane 3-butyl, at number 3 position hydroxy group is beta oriented. Why slow rate of reaction? A reason is that the both halogen hydroxy group and chlorine groups are di-equatorially oriented. No stereoelectronic factor is present in this case. That is no transdiaxial situation, and in order to achieve the transdiaxial situation, ring A, first ring is converted into boat conformation, that is conformational change takes place, that is the ring flipping takes place, partial ring flipping. Now after conformational change, these hydroxy and Cl group, they goes towards the diaxial position. Now transdiaxial situation becomes available, that is a stereoelectronic factor becomes available, and which is required for epoxidation reaction. Now then after addition of base, the nucleophile O minus will be attacked from backside of the Cl, and Cl is given out. Here I have given the mechanism and formation of epoxide. Now here epoxide formation takes place, but again boat conformation is unstable, and therefore again in order to get the stability, conformational change again occur, and the boat conformation, unstable boat conformation is converted into stable chair conformation, formation of epoxide. So what was the question? Question was that why 3-chlorocolestane 2-butyl is reacts epoxidize faster as compared to 2-alpha chlorocolestane 3-butyl. The reason is that in di-equatorial isomer, the epoxidation reaction is not easily takes place because no stereoelectronic factor is present. In order to attain the transdiaxial situation, molecule goes into the boat conformation. Boat conformation will be the unstable conformation, and this step require conformational change. This step require more time to attain, and this is a rate determining step. This step affect the overall rate of the reaction, and therefore slow epoxidation reaction. This is the question. This is the answer of this question. So very important thing is that stereoelectronic factor is responsible for the fast epoxidation reaction, and it must be present. Then and then epoxidation reaction will be possible. Otherwise, epoxidation reaction will be difficult. Okay, in this way we have studied the epoxidation reaction also require the transaxial situation. Okay, we will stop here, and in next lecture we will meet again with new topic. Thank you very much.